Hello friends, we are going to discuss earthing calculations and we are going to start the series for the earthing calculations. In first part, we are going to discuss calculations as per the IS 3043. So what are the procedure for the earthing calculations? We will discuss. So first step is we calculate the area of cross section. Conductor cross sectional area in square mm is given by the following formula. Here S is equal to I root T upon K. So S is equal to conductor cross sectional area in mm square. I is the average fault current in kiloampere. T is the fault current duration in second. K is the material constant. Material constant is calculated as per the following formula. K is equal to QC root of QC B plus 20 divided by delta 20. So here QC is the volumetric heat capacity of the conductor material, which unit is joule per degree Celsius mm square. B is the reciprocal of the temperature coefficient of resistivity at 0 degree Celsius for the conductor degree Celsius. Delta 20, it is the electrical resistivity of the conductor material at 20 degree ohm mm. So this is the formula for the material constant K, which is a very important one for steel, aluminium and copper. What are the values we will discuss here. 1 joule is equal to the watt into seconds. Some basic formulas are there. Energy joule equal to power watt into time. So this one another one basic formula where the resistance at the initial temperature and final temperature we can calculate. So this is R2, resistance at temperature 2 is equal to R1 in bracket 1 plus alpha into temperature 1, and in this is temperature 2 minus temperature 1. So this is the temperature of the conductors, final temperature and initial temperatures. This conductor's temperature and other properties are required for the K factor. So we have just discussed this formula. Resistance of the conductor at temperature 2 means final temperature and initial temperature. This initial temperature may be ambient temperature of the surrounding. So calculations we will discuss now. Earthing calculations. Calculation of the material constant steel. K factor has been arrived considering the normal conditions. Volumetric heat capacity we have for steel 0.0038. Reciprocal of the temperature coefficient of the resistivity at 0 degree for conductor B is B degree Celsius is 202. So it is temperature coefficient of resistivity. Temperature coefficient of the resistivity. Electrical resistivity of the conductor at 20 degree delta 20 is 0.000138, and using equation 2 K factor is calculated. It is equal to 80 for the steel for steel material. Okay, so volumetric heat capacity, what is it? Volumetric heat capacity, the heat capacity of the material per unit of the volume, or the ability of the something to hold, absorb or receive. Means how much heat is withstood by the conductor without getting melted. This is the volumetric heat capacity. Now we will calculate the resistance, cross-sectional area of the conductor. So here area of conductor is calculated following, considering following. This is the average fault current is 50 kiloampere. Fault duration in second is 1 second. Then material constant is 80. So considering this, S is calculated is equal to 625 mm square mm. Then allowance for the corrosion 1% per year is considered. Number of years considered before the replacement, say 20 years. Total allowance will be 20 into 20% allowance. Safety factor 1.5%. So the conductor cross-sectional area is equal to cross-sectional area into total allowance and safety factor. It is now coming to be to the 1125 mm square. So conductor size total considered 1200 mm square, which will be two runs of 6 into 100 mm. Like this, we select the 12 mm into 100 mm. Like this, 1200 is selected. So this is how the resistance at temperature 2 is calculated. This is the formula we have discussed earlier. So now resistance of the earth electrode. Now we calculate the number of earth pits. So earth electrode we considered pipe or cast iron. Pipe of cast iron. Fault current is 50 K. Diameter of pipe is 100 mm. Length is 3 meters. Soil resistivity of ohm meter. Soil resistivity is 72.44. Fault duration 1 second. So current density is given by the formula 7.57 into 10 raised to 3 by divided by root of rho into T. So rho is soil resistivity, T is the duration of fault. Maximum allowable current density is given by this formula. As we calculate, it will be the 889 ampere per meter square. Then surface area of the 100 mm diameter 3 meter long earth electrode will be 2 pi L 2 pi RL for pipe. So surface area calculated will be 0.942 meter square. Length is 3 meter. Radius pi RL. Radius and length are required for the surface area. So maximum current dissipated by one earth electrode will be equal to current density into surface area of the electrode. So surface area and current density is multiplied and it will be rounded to 833. So number of earth electrodes required will be 50 K 50,000 divided by 838. So this 838 is the maximum current dissipated by one earth electrode, which is equal to current density into surface area of electrode. So the number of earth electrodes will be 60. So this is the surface area, surface area of cylinder. This is a cylinder, suppose, and this radius and height. Height means length, we can say. This is unfolded, and this will become a rectangular. So area of a circle will be pi r square, and area of the rectangle will be twice the pi r square, and this length and this pi d. Cylinder surface area is lateral. Curved surface area lateral. Total surface area will be 2 pi r into h. It is a 2 pi height into circumference. This is circumference. Pi d is the circumference. Pi d is the circumference. So base area 2 into pi r square base area, and this curved surface area. Curved surface area is here. Curved surface area, that this is unfolded, and this will become this is the circumference into height. Is height into width. Area of the rectangle, and these two circles means base areas, and this is curved surface area. So surface area of the cylinder is calculated like this. So this will be the number of earth feet. Now we will calculate earth electrode resistance. So formula for the resistance of the earth electrode, resistance of the electrode will be 100 rho divided by 2 pi L log 2 into L divided by D. So this is the formula for the resistance. Then the resistance ohms 0.7994. This is a earth electrode resistance for the single electrode resistance. So overall resistance of the 60 electrodes will be 0.0133. So this single earth electrode resistance is divided by 60 numbers. These are connected in parallel, so it is divided by 60. Earthing strip conductor. For in case of the earthing strip conductor, the formula is 100 by rho 100 rho divided by 2 pi ls into log natural log 4 into ls square divided by wt. So here w is the depth of the burial, t is the width of the strip, length ls or length of the strip. So these are the values. So resistance R2 is calculated is 0.0050. So this is a strip to be earth, and these are the electrodes. So these two formulas we get the resistance. Now equivalent resistance, earth resistance is calculated. Earth resistance due to the pipe electrode R1 is 0.1, 0.0133, and earth resistance due to the earthing strip R2 in ohms 0.005. So net resistance will be R1 into R2 divided by R1 plus R2, which will be 0.036. So this is in very limit, and our resistance is required to be maintained below 1 ohm. Surface area of earthing strip, surface area, how surface area is calculated? There are two number of strips. This height of the strip, length of the strip, and width of the strip. So here surface area is two surfaces, 2 into 2 lbh, two sides, this top side and bottom side, L, B and H is height, this width, W is B. So this will be the 2LW, 2LH, 2WH. This is the surface area for the earthing strip. Okay. Now this is complete theory we have learned about the IS 3043, how conductor cross-sectional area is calculated, how number of earth electrodes are calculated, and then how the resistance of the earth pit earthing grid is calculated. So for a pipe and strip earthing strip, these are different. So here once again we can discuss. Here is the K factor we calculated, formula for the K factor. This is the resistance for the plate resistance. There is a pipe electrode resistance is calculated, and strip resistance, strip, pipe and earth plate. These are three different formulas. So this is enough for today, and we will discuss now IEEE 80 earthing calculations in next lecture. Thank you. Kindly subscribe the channel and get the more knowledge and update, and share your thoughts.